Plane analytic geometry, parabola. At the end of this video, you should be able to graph parabolas with vertices at the origin and write equations of parabolas in standard form. A parabola is the set of all points xy in a plane that are the same distance from a fixed line called the directrix and a fixed point called a focus. Look at figure 1. The axis of symmetry passes through the focus and vertex and is perpendicular to the directrix. The vertex is the midpoint between the directrix and the focus. The line segment that passes through the focus and is parallel to the directrix is called the latus rectum. And the endpoints of the latus rectum lie on the curve. By definition, the distance d from the focus to any point on the parabola is equal to the distance from P to the directrix. To work with parabolas in the coordinate plane, we consider two cases. First, parabola with a vertex at the origin, and second, parabola with a vertex at a point other than the origin. In this video, we begin with the first case. Now, look at figure 2. Let xy be a point on the parabola with vertex 0, 0, focus 0p, and the directrix y equals to negative p. The distance d from point xy to point x negative p on the directrix is the difference of the y values. Therefore, d is equals to y plus p. The distance from the focus 0p to the point xy is also equals to d and can be expressed using the distance formula. Therefore, d is equals to square root of x squared plus y minus p squared. Deriving the equation of a parabola. Set the two expressions for d equal to each other and solve for y to derive the equation of the parabola. We do this because the distance from xy to 0p equals the distance from xy to x negative p. Then, square both sides of the equation, expand the squared terms, and simplify by combining like terms. Therefore, we get the equation of parabola x squared equals to 4py. The equations of parabolas with vertex 0, 0 are y squared equals to 4px when the x-axis is the axis of symmetry and x squared equals to 4py when the y-axis is the axis of symmetry. The following table summarizes the standard features of parabolas with a vertex at the origin. The key features of a parabola are its vertex, axis of symmetry, focus, directrix, and latus rectum. From the figure, when p is greater than 0 and the axis of symmetry is the x-axis, the parabola opens right. When p is less than 0 and the x-axis is the axis of symmetry, then the parabola opens left. For the case when p is greater than 0 and the axis of symmetry is the y-axis, the parabola opens up. And when P is less than 0 and the axis of symmetry is the y-axis, the parabola opens down. Procedure for graphing a parabola with vertex 0, 0. First, determine which of the standard forms applies to the given equation. Y squared equals to 4px or x squared equals to 4py. Second, use the standard form identified in step 1 to determine the axis of symmetry, focus, equation of the directrix, and endpoints of the lattice rectum. If the standard form is y squared equals to 4px, the axis of symmetry is x-axis or y equals to 0. Set for p equal to the coefficient of x in the given equation to solve for p. If p is greater than 0, the parabola opens right, but if p is less than 0, the parabola opens left. Then, use p to find the coordinates of the focus P0, the equation of the directrix x equals to negative p, and the endpoints of the lattice rectum p plus minus 2p. If the standard form is x squared equals to 4py, the axis of symmetry is y-axis or x equals to 0. Again, set for p equal to the coefficient of y in the given equation to solve for p. If p is greater than 0, the parabola opens up. But if p is less than 0, the parabola opens down. Then use p to find the coordinates of the focus 0p, the equation of the directrix y equals to negative p, and the endpoints of the lattice rectum plus minus 2p p. And then finally, plot the focus, directrix, and lattice rectum and draw a smooth curve to form the parabola. Example, graph y squared equals to 24x. Identify and label the focus, directrix, and endpoints of the lattice rectum. Solution. The standard form that applies to the given equation is y squared equals to 4px. Thus, the axis of symmetry is the x-axis, which is y equals to 0. Set for p equals to 24. Therefore, p equals to 6. Since the value of p is positive, the parabola opens right. The coordinate of the focus are P0, which is equals to 6, 0. The equation of the directrix lines is x equals to negative p or x equals to negative 6. The endpoints of the lattice rectum have the same x coordinates at the focus. To find the endpoints, substitute x equals to 6 into the original equation, y squared equals to 24x, and solve for y. Therefore, the endpoints of the lattice rectum is 6, positive 12, and 6, negative 12. Next, plot the focus, directrix, and lattice rectum and draw a smooth curve to form the parabola. Writing equations of parabolas in standard form. In the previous example, we used the standard form equation of a parabola to calculate the locations of its key features. Now, we can also use the calculations in reverse to write an equation for a parabola when given its key features. Given its focus and directrix, write the equation for a parabola in standard form. First, we need to determine whether the axis of symmetry is the x or y axis. If the given coordinates of the focus have the form P0, then the axis of symmetry is the x-axis. Therefore, we use the standard form y squared equals to 4px. But if the given coordinates of the focus have the form 0p, then the axis of symmetry is the y-axis. So, we use the standard form x squared equals to 4py. Then, multiply 4 and p. Substitute the value from step 2 into the equation determined in step 1. Example: what is the equation for the parabola with focus negative half 0 and directrix x equals to half? Solution: the focus has the form P0, so the equation will have the form y squared equals to 4px. Multiplying 4 with p, we have 4p equals to negative 2. Substitute 4p equals to negative 2 into the standard equation. We have the equation for the parabola y squared equals to negative 2x. Try each of the given equations. Watch the next video on graphing parabolas with vertices not at the origin.